Okay, we will begin with inverse variation on page 284 in your textbook. I want you to look at the activity, inverse variation. Read along with me. Suppose you are part of a volunteer crew constructing affordable housing. Building a house requires a total of 164 workdays. For example, a crew of 20 people can complete the house in 8 days. If 20 people can complete the house in 8 days, how long should it take a crew of 40 people? Copy and complete the table. What do you notice is happening as the crew size, X, is getting larger? What is happening to the number of construction days, Y? Yes, Kylie, they are just decreasing. As your value of X is increasing, your value of Y is decreasing. When we did direct variation, whatever was happening in the value of X, or the domain, the same thing happened in the range, the Y. But this time in inverse variation, whatever is happening in the X or the domain, the opposite is happening in the range, or the Y. So what happens in an inverse variation? Well, here's what happens. In an inverse variation, I'm not being cooperative this morning. In an inverse variation, the values of two variables, which are X and Y, change in an opposite manner. As one value, X, increases, the other value, Y, decreases. Okay, that's the mathematical term. Basically, we're saying as X increases, Y will decrease. Or as X decreases, Y will increase. As you write that down, we will move to the next section of our notes, which is the definition for an equation. So here, what happens in an inverse variation? As X increases, Y decreases. Or as X decreases, Y increases. The definition or the equation. Here is your definition. You can remember that in a direct variation we had a k as a constant. Y equals kx. That was with direct. Inverse, you've got the form xy equals k. Or y equals k over x. These two equations are equivalent. So when you remember, k cannot equal 0. So when we're looking at our definition or equation, you could say xy equals k, or y equals k over x. So, what are these graphs going to look like? We know that direct variation graphs are linear and they go through the origin of the graph. Here is what inverse variation graphs will look like. You may copy these on the grid that I have given you. We will be doing some graphing on the graphing calculator, but you're entering xy equals k into the calculator as y equals k over x. That's the input that you're putting in. Here's what your graphing calculator would show you, or here is what they are going to look like as you graph them. Notice they don't go through the origin, and notice they're not linear. So take a minute and fill those out, giving yourself some examples of what inverse variations may look like on a graph. The final part of this video is going to be comparing or finding out how to write an equation given a point on the grid. Okay? This follows example number 1 on page 285. So write an equation given a point. Suppose y varies inversely with x and y equals 7 and x equals 5. Write an equation for the inverse variation. Okay, remember our general form is xy equals k. But we've been given a value for x, and that's 5. And we've been given a value for y, and that's 7. So we're going to substitute those values in that I know is x and y. So 5 times 7 is going to equal k. Now we solve for k. Well, 5 times 7 is 35. So now we're going to substitute 35 for k in this equation. xy equals k. So our equation becomes xy equals 35. You could also say, how could I rewrite this, Eric? Y equals 35 over x. That would also be an inverse variation equation. Okay? So looking at your notes, you did that equation with me. So our steps, what are the steps that we use? We substitute for x and y in xy equals k, and we solve for k. Then we rewrite inverse equation with k. All right, you have space for additional practice, so let's look at a few more practice problems here. Suppose y varies inversely with x and y equals -2 and x equals 3. Why don't you try that problem? Okay, Matt, when you did that, did you substitute 3 times -2 in for x and y? And we solve for k. K equals -6. And the equation is xy equals -6. Or, Clayton, what could be another way? Y equals -6 over x. Excellent. Practice a few more. Let's do 1, 2, and 3. You take a minute to do 1, 2, and 3. As you pause the video to finish, I'm going to go ahead and get started. Charlie's going to help me with number 1. 9 times 6 equals k. K will equal 54. Excellent. My equation is xy equals 54. Superb. Justin's going to help me with number 2. 3.6 times 5 equals k. 0, 3. that multiply. Not a good thing to do this early in the morning. About 18 equals K. So just what would my equation be? Excellent. And number 3. Go ahead, Zoe. 3/4 times 2/9 equals K. K equals 1/6. So X, Y equals 1/6. We're all just substituting in values for X and Y when we are writing an equation given a point. We'll have practice problems to work on during class today.